This is the notes for college algebra section 11.1 dealing with sequences and summation notation. Our learning objectives today are to find particular terms of a sequence given a general term, look at how to use recursion formulas, and how to use factorial notation. And then tomorrow we'll focus on this one dealing with summation notation. All right, for sequences and summation notation, it says to find the next 5 terms of the pattern below. So looking at what we're given here, our first term is a 1, our second term is also a 1, our next term is a 2, then a 3, etc. And some of you may recognize this. It is kind of a famous pattern. What we're doing is we're taking the 2 previous numbers and adding them together. So for example, 1 plus 1 will get us this 2. And then 1 plus 2 will get us our 3. And then 2 plus 3 will get us our 5. So the pattern is to take the 2 previous terms, add them together to get our next number. So to find this term, we're going to have to add the 34 and the 55. So we end up with 89. To get our next term, we're going to have to add the 55 and the 89, which gives us 144. And then our last one, we have to add the 89 and the 144 to get a total of 233. And we could continue that on forever. It says to describe the pattern. So we are adding the 2 previous numbers to get the next term. And like I said, this is one of our famous sequences. It is called the Fibonacci sequence. All right, a couple vocab words that we need to understand before we can move on. The first one, a sequence, is a set of numbers that follows a pattern or rule. A term is each of the elements in the sequence. So the terms are often designated with little subscripts, this meaning our first term, a sub 2 would be our second term, etc. All right, the next vocab word. A finite sequence is a sequence that has a last term. In other words, it ends. There's a stop to it. An infinite sequence is one that has no last term. It continues on forever. So example 1 says to write the first 5 terms of the sequence from the general term. So this right here, a sub n, stands for our general term. In other words, it's just representing any term in the sequence. The n represents the position it is in. So when n is 1, we are finding the first term. So a sub 1 means I've plugged a 1 in for n, which means I have to plug a 1 into my formula here for n, and then complete it. So 3 times 1 plus 4 gives me a first term of 7. My second term means I plug a 2 in for n. So 3 times 2 plus 4, which gives me 10. My third term, 3 times 3 plus 4, which gives me 13. And then we continue for our fourth term. We're plugging a 4 in for n. We should get 16. And our fifth term, which is the last one they asked us to find, we take 3 times 5 plus 4, and we get 19. Okay. For our second part, our general term says we are taking negative 1 to the nth power, and we're dividing by the expression 2 to the nth plus 1. So a sub 1 is going to be negative 1 to the first power divided by 2 to the first power plus 1. Well, negative 1 to the first is negative 1. 2 to the first is 2 plus the 1 gives us a 3. So the first term in this sequence would be negative 1/3. My second term, I'm going to substitute all my n's with a 2. So I have negative 1 squared, which becomes a positive 1. And then on the bottom, in the denominator, we have 2 squared, or 4, plus 1, we get 5. So 1/5 would be the next term in my sequence. My third term is going to be negative 1 to the third power divided by 2 to the third plus 1. Negative 1 cubed is negative 1. 2 cubed is 8 plus 1 gives me 9. My fourth term, negative 1 to the fourth power over 2 to the fourth plus 1, we end up with 1 over 17. And my fifth term, negative 1 to the fifth over 2 to the fifth plus 1 gives me negative 1 over 33. All right, so the next terms that we're going to look at, we have the term explicit and recursive. Some of the equations will be given, or some of the rules will be given as an explicit formula, while others will be a recursive formula. An explicit sequence allows you to find any term by inserting the term number into the general form. So kind of like the ones we just did, we found the first 5 terms, but we could have said, locate the 27th term, and found it simply by putting a 27 in for n. So an explicit rule basically says you can find any term in the sequence by simply replacing the n with the position you want it to be. In a recursive rule, a recursive sequence, the term has to be found based on the previous terms. So that very first example that we looked at, the Fibonacci sequence, that was a recursive sequence because we needed the previous numbers to find the next ones. All right. Question 2. Find the first 5 terms of the recursive sequence. Now there's a couple things that should jump out at you to let you know that this is a recursive formula versus an explicit one. A recursive one is going to have to tell you the first term, which it does here. It says that our starting number is a 5. We have to know that because all the terms after that are based on the previous numbers. So we have to have a starting point. The second thing that points us to the fact that this is a recursive sequence is that in our formula, in our rule for the nth term, we have this expression right here, this little a sub n minus 1. And a sub n minus 1, I want you to think of as the previous term. Okay? So in our list of numbers, if we're finding a sub n, then a sub n minus 1 is going to be the one right in front of that. All right, so it asks us to list the first 5 terms. We are going to think of this as 3 times the previous term plus 2. Okay, so they gave me the first term is 5. Now the second term says take 3 times the previous answer and add 2. All right, so we are going to dump this 5 in here, and 3 times 5 is 15 plus 2 gives us 17. Then to find the third term, a sub 3, it's 3 times the previous number plus 2. My previous number this time is a 17, so 3 times 17 plus 2 gives me 53. My fourth term is going to be 3 times the previous number plus 2. My previous number is a 53. 3 times 53 plus 2 is 161. And then my fifth term, hopefully you're seeing the pattern by now. We're going to dump 161 in there for my previous number. I'm going to times by 3, add 2, and I get 485. So I can label it that way. I can also list my answers in a sequence format. So first term was 5, second term was 17, then 53, 161, and 485. All right, question 3. Determine if the sequences below are defined explicitly or recursively. Then write the first 5 terms of the sequence from the general term. So when I look at the first one here, a sub n equals 3n divided by n plus 5. There is no first term given. There is no indication of that little a sub n minus 1 representing the previous term. So this would be an explicit formula. Okay. In the second one, we are given a first term. We are given this expression a sub n minus 1. So we're basing our formula on the previous answer. So this would be recursive. All right, then it says to find the first 5 terms. So my first term here, I'm simply plugging a 1 in for n. So I have 3 times 1 or 3 over 1 plus 5 or 6. I could reduce that to 1/2. My second term, I have 3 times 2 over 2 plus 5, and I get 6/7. My third term, 3 times 3 over 3 plus 5, or 9/8. My fourth term, 3 times 4 divided by, 4 plus 5. All right, and I get 12 divided by 9. We could reduce that to 4/3. And my fifth term, I have 3 times 5 over 5 plus 5. We get 15 divided by 10, or 3/2 if we reduce. All right, the recursive one says we are going to take 5 times the previous answer and subtract 6. So my first answer is a 2. My second answer is going to be 5 times that previous answer minus 6. My previous answer was 2. I end up with 10 minus 6, which is 10 minus 6, which is 4. A sub 3 is going to be 5 times the previous answer minus 6. Now I can dump in my previous number of 4. I get 20 minus 6, or 14. A sub 4, 5 times the previous answer minus 6. And we could go ahead and do a sub 5, 5 times the previous answer minus 6. Dumping in what we have, a 14 here, gives us 64. And dumping 64 in here will give us 314. All right. Next learning objective we had was to understand factorial notation and use it in a sequence. So to review, n factorial is the product of n times all the numbers starting with n and going down 1 each time until you get to a 1. So for example, if I said to take 4 factorial, that means start with your 4 and times by every number, subtracting 1 until you get down to a 1. So 4 factorial, 4 times 3 is 12, 12 times 2 is 24. By definition, 0 factorial is 1. All right, so example 4 says to evaluate the expression and look at how these are different. In our first one, notice that we have no parentheses. So this is simply 5 times 3 factorial. So we have a 5, and then 3 factorial would be 3 times 2 times 1. So 5 times 3 is 15, times 2 is 30. So we get 30 for an answer here. On this one, it's saying to take 5 times 3, or 15 factorial, which means we have to do 15 times 14 times 13 times 12 times 11, all the way down to a 1. You can use your calculator to do factorials. Entering 15 factorial, you should get an answer of 1.308 times 10 to the 12th. Not one that we'd want to do by hand. Example 5 says write the first 5 terms of the sequence from the general term. These are explicit again because they are allowing us just to plug a number in for n, and we don't need to know the numbers in front of it. All right, so these are both explicit. So a sub 1, my first term, is 2 to the nth power, so 2 to the first, divided by 1 minus 1 quantity factorial. Well, 2 to the first is 2. 1 minus 1 is 0. 0 factorial, remember, is defined to be 1. So we end up with just 2 for an answer. A sub 2 is going to be 2 to the second power over 2 minus 1 factorial. 2 squared is 4. 2 minus 1 is 1. 1 factorial is just 1. So answer is 4. A sub 3 is going to be 2 to the third over 3 minus 1 factorial. Well, 2 cubed is 8. 3 minus 1 is 2 factorial, which means 2 times 1. And 8 divided by that 2 will give us a 4. A sub 4 will be 2 to the 4th power, 2 to the nth power, over 4 minus 1 quantity factorial. 2 to the 4th is 16. 4 minus 1 is 3. 3 factorial means 3 times 2 times 1. Now, we can multiply that out and have 16 divided by 6. We could do some reducing. For example, we could divide a 2 out and make this an 8. We're going to end up with 8/3 either way as our reduced answer. And a sub 5, 2 to the 5th power divided by 5 minus 1 quantity factorial. 2 to the 5th is 32. 5 minus 1 is 4. We need 4 factorial, which we actually figured out earlier today. 32 divided by 4 times 3 times 2 times 1. So 32 divided by 24, we could reduce that and say that is 4/3. All right, part B. It says a sub n equals 20 divided by n plus 1 factorial. So a sub 1 is 20 divided by 1 plus 1 factorial. 20 divided by 2 factorial. 2 factorial would be 2 times 1, which is just 2, reduces down to 10. A sub 2 is going to be 20 divided by 2 plus 1 quantity factorial. So 20 divided by 3 factorial. 3 factorial means 3 times 2 times 1, or 6, and we end up with 10/3. Sorry, 20 divided by 6, not 30 divided by 6. All right, a sub 3, we have 20 divided by 3 plus 1 quantity factorial. So 20 divided by 4 factorial, we said 4 factorial was 24. 20 divided by 24 reduces to 5/6. A sub 4, we have 20 divided by 4 plus 1 factorial. 20 divided by 5 factorial. 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. So we have 20 divided by 120, or 1/6. And then our fifth term is 20 divided by 5 plus 1 factorial. 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. Well, we already did 5 factorial and got 120. Now we just need to multiply the 6 in. So we end up with 20 divided by 720. We could reduce that to 1 over 36. All right, our last example today says to simplify without a calculator, meaning do not use your factorial key. All right, so let's think about what this means. 26 factorial. Now, I don't actually expect you to figure out 26 factorial, but 26 factorial means 26 times 25 times 24 times 23 times 22 times 21, all the way down to 1. But we're dividing by 22 factorial, which is 22 times 21 all the way down to 1. And so most of this is going to cancel out. Your 22s will cancel out, your 21s, everything down to those 1s. So what we really are doing is we are just taking 26 times 25 times 24 times 23. And you can use your calculator to do that part. You should end up with 358,800, so 358,800. Part B says to take 14 factorial. So let's start listing it out. 14 times 13 times 12 times 11 times 10 all the way down to 1. we are dividing by two things, a 2 factorial, which is 2 times 1, and a 12 factorial, which would be 12 times 11 times 10 down to 1. So all of this will drop out. We have this left, and we can even do some reducing here because 2 goes into 14 7 times. So we really just end up with 7 times 13, which is 91. All right, now the last one that we're going to look at does not have numbers involved, just the variable n. Well, n factorial, remember, means n times the number 1 lower, so n minus 1, times the number 1 lower than that, which would be n minus 2, all the way down to 1. N minus 1 factorial says start with n minus 1, multiply by one number lower, which would be n minus 2, all the way down to 1. And everything here will drop out. All we have left is an n. Okay, so for tonight's homework, you are going to be on page 1026. You're going to do questions 2 through 28 even. Be sure to show your work just like I did in our video here today. Good luck.